Water in the desert. Rainfall is not completely absent in desert areas, but it is highly variable. An annual rainfall of 4 inches is often used to define the limits of a desert. The impact of rainfall upon the surface water and groundwater resources of the desert is greatly influenced by landforms. Flats and depressions where water can collect are common features, but they make up only a small part of the landscape. Arid lands, surprisingly, contain some of the world's largest river systems, such as the Murray-Darling in Australia, the Rio Grande in North America, the Indus in Asia, and the Nile in Africa. These rivers and river systems are known as exogenous because their sources lie outside the arid zone. They are vital for sustaining life in some of the driest parts of the world. For centuries, the annual floods of the Nile, Tigris, and Euphrates, for example, have brought fertile silts and water to the inhabitants of their lower valleys. Today, river discharges are increasingly controlled by human intervention, creating a need for international river basin agreements. The filling of the Ataturk and other dams in Turkey has drastically reduced flows in the Euphrates, with potentially serious consequences for Syria and Iraq. The flow of exogenous rivers varies with the season. The desert sections of long rivers respond several months after rain has fallen outside the desert, so that peak flows may be in the dry season. This is useful for irrigation, but the high temperatures, low humidities, and different day lengths of the dry season, compared to the normal growing season, can present difficulties with some crops. Regularly flowing rivers and streams that originate within arid lands are known as endogenous. These are generally fed by groundwater springs, and many issue from limestone massifs, such as the Atlas Mountains in Morocco. Basaltic rocks also support springs, notably at the Jabal al-Arab, on the Jordan-Syria border. Endogenous rivers often do not reach the sea, but drain into inland basins, where the water evaporates or is lost in the ground. Most desert stream beds are normally dry, but they occasionally receive large flows of water and sediment. Deserts contain large amounts of groundwater when compared to the amounts they hold in surface stores, such as lakes and rivers. But only a small fraction of groundwater enters the hydrological cycle, feeding the flows of streams, maintaining lake levels, and being recharged or refilled through surface flows and rainwater. In recent years, groundwater has become an increasingly important source of fresh water for desert dwellers. The United Nations Environment Program and the World Bank have funded attempts to survey the groundwater resources of arid lands and to develop appropriate extraction techniques. Such programs are much needed because in many arid lands, there is only a vague idea of the extent of groundwater resources. It is known, however, that the distribution of groundwater is uneven, and that much of it lies at great depths. Groundwater is stored in the pore spaces and joints of rocks and unconsolidated unsolidified sediments, or in the openings widened through fractures and weathering. The water-saturated rock, or sediment, is known as an aquifer. Because they are porous, sedimentary rocks, such as sandstones and conglomerates, are important potential sources of groundwater. Large quantities of water may also be stored in limestones, when joints and cracks have been enlarged to form cavities. Most limestone and sandstone aquifers are deep and extensive, but may contain groundwaters that are not being recharged. Most shallow aquifers in sand and gravel deposits produce lower yields, but they can be rapidly recharged. Some deep aquifers are known as fossil waters. The term fossil describes water that has been present for several thousand years. These aquifers became saturated more than 10,000 years ago and are no longer being recharged. Water does not remain immobile in an aquifer, but can seep out at springs or leak into other aquifers. The rate of movement may be very slow in the Indus Plain. The movement of saline salty groundwaters has still not reached equilibrium after 70 years of being tapped. The mineral content of groundwater normally increases with the depth, but even quite shallow aquifers can be highly saline,